Now, before we pick up with new material today, I'd like to review a little bit of the material from last class. So can somebody tell me what it means when I say that every element has a valence set of electrons? Okay, so whatever electrons are in the outer shell, those are the valence electrons. Okay? Can somebody tell me what term is used to describe an element's propensity to obtain electrons? Electronegativity is correct. Absolutely. Let's see, what else we talked about yesterday or last class. Oh, what do we call those funny little structures with the dots all over the place? Lewis structures. Now, let's take this up a notch. Can somebody tell me why we even bother drawing Lewis structures? I mean, is it just because I want to make you unhappy? It gives you a better mental image of how it works. It gives you a good image of how the atoms are aligned, where they're positioned. But more importantly, or should I say most importantly, it tells you where the electrons are. You're going to find that organic chemistry is all about the electrons. Okay, it's the motion of electrons. It's the electrons dragging one element to react with another element. All right? Now, what were the three different types of bonds that we discussed? Ionic, covalent, polar covalent. Very good. Okay, and what is the property, or what decides whether or not a bond is going to be polar, ionic, or covalent? Okay, that's the difference between covalent and ionic, whether or not you've actually transferred electrons over or whether or not you're sharing electrons. Can somebody tell me how I know the difference between a covalent bond and a polar covalent bond? Right, just look at the electronegativity difference. And how can I tell the difference in electronegativity between two elements? Right. So the trend is, if I go up the periodic table, electronegativity increases or decreases? Increases. And as I go from left to right, does it increase or decrease? Increases. So it's increasing going this way and that way. Okay? Now that's not absolute. Okay? It just gives you a rough idea. If you're trying to determine what's more, or try to determine the polarity of a bond between nitrogen and phosphorus, and for those of you who have a periodic table, you would see nitrogen and phosphorus are right on top of each other. You can't really say absolutely with a lot of comfort that the bond is going to be polar or very polar or less polar. Okay, but for the more extreme cases, you can make those predictions. Okay. Now, can somebody give me an example of a covalent bond? Somebody from the back here. A purely covalent bond. No polar nature at all.
When they share it exactly equally.
Can you give me an actual molecular example? N2, perfect. Dinitrogen. Anytime you have two atoms of the exact same identity, you're going to have a perfectly covalent bond. Okay, very good, very good. Now, the next thing I want to kind of get into here is to finish up a little bit of material that I wanted to talk about when we were at the end of last class. What were those big red letter words that I put up on the board? 4 bonds to carbon, never 5 bonds to carbon.